Hello guys, how are you? I hope you're doing good. Okay, in this video we're gonna continue studying electricity, and now we're gonna learn how to work out variables but in a circuit with more than one load device. Okay, so we already know how to calculate the voltage, the current and the resistance in a circuit with just one load device by using the Ohm's law. Remember, these are the formulas. And remember, you have this trick to remember all the three formulas to solve the circuit, to work out the voltage, current and the resistance. Okay, now we're going to learn how to calculate the electric variables, but in a circuit with more than one load device, with more than one resistance. So remember, the series connection is when we have more than one load device and they are all connected in the same cable, one after the other. Okay, and remember as well that when we are calculating things in electricity, normally instead of drawing the symbols, we draw the symbol of the resistance, because for the electricity it doesn't matter we're going through a lamp, a motor or buzzer. For the electricity everything is a resistance. And remember that we can use this symbol or this other symbol. So if we have this circuit, we will draw it this way, or we will draw it this way. So when we have a series circuit, these are the formulas we're gonna use. First of all, we will start by calculating the total or equivalent resistance of the circuit. It's very easy, you only have to add them. Next step will be to work out the total current. For that we will use the Ohm's law with the total voltage and the total resistance we already calculated. As you know, as you remember, in series connection the current is the same through all the three resistance, so the current would be the total we already calculated, and we will see later how to work out the voltage drop in each resistance. So let's start with this example in which we have this circuit with these three resistance. So as I say, the first step is working out the total resistance. So for that we only have to add the three numbers. We have three, we have here. So we have 2 ohms, 3 ohms, 1 ohm. So we add them. It means that this circuit has an equivalent resistance of 6 ohms. So we could replace this circuit by one with just one resistance, which value is 6 ohms. We need that to work out the total current. Okay, now we can apply the Ohm's law to the circuit. So as we know the total resistance, the current is the result of dividing the total voltage by the total resistance. So it's 12 volts, we have the data here, and 6 ohms we already calculated here. So the current going through this circuit is 2 amps. And in series connection we know that the current is the same, because there is no other way for the current to go. So the current is the same in all the three resistance. So as we already know, the total current is 2 amps, mean that we have 2 amps through each resistance. Now to work out the voltage, we're gonna stop for a moment, and we're gonna remember the difference between voltage and electric current. So remember that the voltage is the difference in charge between 2 points. So we have a battery with 6 volts. It means that I have 6 volts here, but at the end of the circuit we have 0 volts. While the current is the number of electrons through a conductor over a period of time. So this is like, imagine that you have a city here with different cars. They live in the city, they go into another city. So the current would be the number of cars going through the motorway. So we have 3 cars, it means that we have 3 amps. We have 3 cars going through the road. But the voltage would be like the petrol they have in the tank. So they start full of petrol, and when they get to the destination they have no more petrol in the tank. So this is the voltage. So we have a circuit, imagine that we have a circuit with a battery and a resistance. We count the number of electrons, that would be the current. Okay, imagine you have this electron, they are full of energy here and they are getting with no energy. So this is a conductor, a wire, and this is a resistance. Remember, we consider conductors like something that make the electron go freely. They don't waste their energy in a conductor, they waste their energy in a resistance. So the current, as I say, is the number of electrons through a conductor. So we count the number of electrons here, we measure this with the unit is ampere. This is the current. So we have the same current here, the same current here, and the same current here. while the voltage is how full of energy the electrons are at the beginning. So at the end they have no energy. So the voltage here, imagine that for example we have 12 volts, it means that the electrons before getting to the resistance they are full of energy. They have 12 volts, but as long as they are going through the resistance they get exhausted and they have no energy at the end, so they have 0 volts. Okay, can you see the difference? So if we have 3 resistance, the point is that the electrons are losing their energy in each resistance. Okay, in every resistance, every time they go through a resistance, their voltage drops. So you can see here the electrons are full of energy, they have less energy here, less voltage, and they have no voltage at all here. Okay, if the resistance are the same, equal resistance, imagine that we have 12 volts here, so the voltage drop is the same in each resistance. We would have 8 volts here, 4 volts, and they have no more energy at the end of the circuit. Okay, so the voltage drop in this case is 4 volts. Okay, we have 12 volts here, there is a drop of 4 volts in this resistance, another 4 volts of drop here, and another 4 volts here. So we have V1, V2, V3 in this case would be the same, would be 4 volts. Okay, but if we talk about current, the current is the same. We count the number of electrons going through this resistance, is the same number of electrons going through this resistance and through this one. Imagine that we have 2 amps, so we have 2 amps, 2 amps, and 2 amps. Okay, remember the voltage drop and the current is different. Normally the resistance are different, so in this case the voltage drop is different. Mind that we have a resistance with 2 ohms here, 3 ohms, and 1 ohm, so we will have more voltage drop with a higher resistance. Okay, it's easy to understand because the electrons are losing their more energy when they had to go through a high resistance. It's more difficult for them to go through this resistance than through this one. So for example here we will have a drop of 4 volts here, they are losing 4 volts here. In this resistance they are losing 6 volts because this resistance is higher. Okay, and this resistance is very low, it's just 1 ohm, so they are losing just 2 volts. Okay, let's see how can we apply this to a circuit. So remember we have this circuit, we already solved the real equivalent resistance, that is 6 ohm, and we already calculated the current is 2 ohm, and now we have to work out the voltage drop in each resistance. How do we do it? Very easy. We only had to use the Ohm's law, but this time in every resistance. So we look for the first resistance, which value is 2 ohms, and the voltage drop between this point and this point is the result of multiplying the current by the resistance. The current we know is here, is 2 ohms. The resistance we know as well is here, so it's 2 by 2 is 4 volts. So there is a drop, voltage drop of 4 volts in this resistance. Now we're gonna work out the following voltage. We do the same, we multiply the current by the resistance. The current is the same again, and the resistance now is 3 ohms. So there is a voltage drop of 6 volts between this point and this point. Finally, the last resistance, we do the same. Now we have again 2 amps and we have 1 ohm. So we multiply, so we have 2 volts. So it means that there is a drop of 4, 6, and 2 volts. So it's different because the resistance are different. The total voltage drop has to be 12. So this is a way to make sure that we did it right, that our calculations are right. So if we had to add all the 3 voltage, and the result has to be 12 volts. Okay, 12 here, 0 here. So as a summary, this would be the circuit with all the calculation. This is a circuit with 12 volts. The total current is 2 amps. The individual current is 2 amps because they are in series connection, and the voltage drop in this resistance is 4 volts, in this one is 6 volts, and in this one is 2 volts. Okay, now it's your turn to solve a different circuit. Goodbye.